Verify that f of x equals 2x squared plus 3x minus 1 on the closed interval from 0 to 2 satisfies the mean value theorem, and find all numbers c that satisfy its conclusion. Now, to make sure that this function is going to satisfy the mean value theorem, we need to make sure that it is continuous on the closed interval from 0 to 2 and differentiable on the open interval from 0 to 2. And we're in luck because this is a polynomial function, so it is continuous and differentiable everywhere. So we know it satisfies the requirements of the mean value theorem. So what we need to do is we need to find all numbers c in that interval that satisfy its conclusion. So we need to find values of c such that f prime of c is equal to f of 2 minus f of 0 over 2 minus 0. So first of all, we can actually do this in either way. We can do the derivative first, or we can calculate the right-hand side first. Let's calculate the right-hand side. F of 2, our function value at 2 is going to be, what is this? 2 squared is 4, times 2 is 8. So we've got 8 plus 6 minus 1. Why not write that out? 8 plus 6 minus 1. Minus f of 0 is just negative 1, because all the x terms go away. And that's all going to be over 2. So we've got 8 plus 16 is 14, minus 1 is 13. And subtracting a negative is the same as adding. So it's going to be 13 plus 1 over 2, which is 14 over 2, which becomes 7. So we need the derivative to equal 7. Now, if we differentiate that function, f prime of c, let's differentiate but also have it in terms of c. So the derivative of this function is 4x plus 3, but that's going to be 4c plus 3 in this case. And we know that this needs to equal 7. Well, if we subtract 3 from both sides, that gives us 4c equals 4, which is equivalent to c equals 1. So that is our value, and it is in the open interval from 0 to 2. That is the value that satisfies the mean value theorem. So we're good to go.